This question, they give you a quadratic equation involving sine ratio, and then they limit a certain region for x. To solve this kind of equation, let me remind you, never divide both sides by unknown. So don't divide both sides by sine x, otherwise you're missing one of the or some of the solution. So the first thing to handle the quadratic equation is always put everything to one side. And then you extract the common factor. And then we can say by zero product rule, something times something equals 0. That means the first factor may equal to 0. If not, then another factor should equal to 0 to get the zero product. So sine x is equal to 1 over 7. Then you can use a calculator method or some trigonometric ratio within 360 degrees. And I think the best method is to consider the function. You sketch the function by yourself. The function is like this within 360 degrees. Beware that if the question gives us more possibility, that means the range is wider, then we may find more roots to fulfill the requirement. So when sine x equal to 0, beware that we can choose 0 and we can choose 360 degrees. So for sine x equal to 0, we find one solution, and the third solution, so that the height of this graph is 0. And then we are going to search what x will give us 1 over 7 as a result. So we find 1 over 7 is around here. And then we use a line. We check that, oh, this input and also this input will give us 1 over 7. So together we have 1, 2, 3, 4, 5. We have 5 roots in total. Furthermore, if you need to find out the exact position of these roots, then what you can do, by doing this, you're considering when x is within 0 and 90 degrees, then sine x equal to 1 over 7, then x will equal to 8.21 degree. So this is 8.21 degree. But how can we find out this? It's because this is 180 degree. So this is 180 degree minus it. If you still remember the circle, they give you the height is 1 over 7. This is the first position. And then we have another position here, which is 180 degree minus theta. So this is 180 degree minus 8.21 degree. So that's how you can find out the exact position of our sine function roots.